far we have discussed the position of a line with respect to circle in a plane and the condition that the line is a tangent to the circle and the slope form of the tangent to the circle and the equation of the tangent and normal at both Cartesian point P x1 y1 and theta to the circle and the chord joining the points P x1 y1 and Q x2 y2 the Cartesian points and theta 1 theta 2 the parametric points to the circle and finally the length of the chord intercepted by the circle, which are essential and prerequisites for the 1C exercise. Therefore, we shall start the 1C exercise now. Exercise 1C. So, first problem. Find the equation of the tangent at P of the circle S is equals to 0, where P and S given by P. First question, second bit, P minus 1 comma 1 and S x square plus y square minus 6x plus 4y minus 12 is equals to 12. So that means this is the circle given and this is P minus 1. For example, this is P minus 1 comma 1 and we are required to find out the equation of this tangent. So solution, the equation of the tangent at Px1 comma y1 to the circle S is equals to 0 is S1 equals to 0. That is, what is S1 equals to 0 for this? X1 plus y1 minus same. The sign is not going to be changed. So half of the quotient of x, which is 6 by 2, which is 3 into x plus x1 plus y quotient is 4, half of that. So 2 into y plus y1 minus 12 equals to 0. So substitute. This is x1 comma y1. So x into minus 1. So minus x plus y into 1. So y minus 3 into x plus x1 is minus 1 plus 2 into y plus y1 is plus 1 minus 12 equals to 0. So this is minus x, this is minus 3x plus y plus 2y. So minus into minus plus 3 ones are 3, 2 ones are 2, minus 12 equals to 0. So that further implies minus x minus 3x is minus 4x, 2y plus y is 3y. So 3 plus 2, 7, 3 plus 2, 5 minus 12, minus 7 equals to 0. If you take out minus as a common factor, 4x minus 3y plus 7 equals to 0 is the required tangent. Second, find the equation of the normal at P of the circle S is equals to 0, where P and S are given by. Second question, second bit, P equals to 3 comma 5 S x square plus y square minus 10x minus 2y plus 6 equals to 0. Minus 10x minus 2y plus 6. Solution, this is x1 y1. So we have the formula equation of the normal at P x1 comma y1 is x minus x1 into y1 plus f minus y minus y1 into x1 plus g equals to 0. So the earlier question is the circle is given and the point P is given, and we are required to find out the equation of this tangent earlier. Now here we are required to find out the equation of the normal. So we have already discussed that the normal is perpendicular to the tangent and always passing through, normal is always passing through the center of the circle. So this is the tangent and while this is a normal. So this is C. So for this circle, what is minus g minus f? Here, if we apply, if we compare this with the general equation of the circle x square plus y square plus 2gx plus 2fy plus c is equals to 0. 2g is equals to minus 10 implies g is equals to minus 10 by 2, which is minus 5. So f equals to, likewise, 2f is equals to minus 2 implies f equals to minus 1. So if we substitute these values, x1, y1 we have, and g comma f values also we have. So simply substituting in this. So x minus x1 is 3 into y1 is 5 plus f is minus 1 minus of y minus y1 is 5 into x1 plus g, 3 plus g value is minus 5 equals to 0. So 5 minus 1 is 4 into x minus 3 minus 3 minus 5 is minus 2, minus of minus plus 2 into y minus 5 equals to 0 implies 4x plus 2y, 4 3s are minus 12, 2 5s are minus 15. So minus 27 equals to 0 is the equation of the required normal. Implies 4x plus 2y, 4 3s are minus 12, 2 5s are minus 10, minus 22 equals to 0. Therefore, if you cancel 2 throughout the equation, 2x plus y minus 11 equals to 0 is the equation of the required normal. Now, second question, third way. This time P is 1 comma 3, which is x1 comma y1, and S is 3 into x square plus y square minus 19x minus 29y plus 76. So first let us take 3 as a, let us divide this with a 3. So x square plus y square 9 minus 19 by 3 x minus 29 by 3 y plus 76 by 3. 76 by 3 is equals to 0. Now here 2g is equals to minus 19 by 3 implies g is equals to minus 19 by 2 3s are 6 and 2f is equals to minus 29 by 3 implies f equals to minus 29 by 2 3s are 6. So equation of the normal is x minus x1 into y1 plus f minus y minus y1 into x1 plus g equals to 0 minus x1 value is 1 into y1 value is 3 plus f minus 29 by 6 minus y minus y1 3 x1 plus g. X1 value is 1, g value is minus 19 by 6 equals to 0. So x minus 1, 3 6 are 18 minus 29 minus 11 by 6 minus y minus 3, 6 1s are 6 minus 19 minus 13 by 6 equals to 0. That implies minus 11x minus into minus plus 11 1s are 11 minus into minus plus 13 into y 13y minus into minus plus into minus minus 3 13s 39 whole by 6 equals to 0. This implies minus 11x plus 13y. So 11 minus 39 minus 28 equals to 0. Therefore, if you cancel minus throughout the equation, 11x minus 13y plus 28 equals to 0 is the required normal. Now, second Roman, first question. Find the length of the chord intercepted by the circle S. X square plus y square minus x plus 3y minus 22 equals to 0 on the line L. Y equals to x minus 3. So this is the question given. Find the length of the chord intercepted by the circle. For example, this is the circle S equals to 0. Let us suppose that this is the line. This is the line. L equals to 0. So, if I drop a perpendicular here, this is my D. What is D? Perpendicular distance from the center of the circle to this line. So, what is the center of this? C is equals to, so if here minus is there, you take the opposite sign. So, x quotient is 1, it's half. So, here plus is there, minus you take, y quotient is 3, half of that. So, this is C, 1 by 2 comma minus 3 by 2. And what is this line L? L is x minus y minus 3 equals to 0. So, this line is x minus y minus 3 equals to 0. So, in morning, yesterday morning we have discussed that the length of the chord intercepted by the circle s is equals to 0 is 2 root of r square minus d square. What is r here? Radius is equals to square root of g square 1 by 2 whole square plus f square 3 by 2 whole square, which is 9 by 4, g square plus f square minus c, minus of minus is plus 22. So this is 9 plus 1 10, 422 sir, 88 plus 1, so root 98 by 4. So 4 2's place personnel C. So what is the radius? Square root of g square plus f square minus c. Square root of g square is 1 by 2 whole square 1 by 4 plus f square 3 by 2 whole square 9 by 4 minus c. Minus of minus is plus 22. So that is equals to 1 plus 9 10 plus 4 22 is 88 by 4, which is equals to root 98 by 4. Okay. And so what is the length of the chord intercepted by the circle s is equals to 0 is 2 root of r square minus d square. So r is the radius and d is equals to what? Perpendicular distance from center of the circle C 1 by 2 comma minus 3 by 2 to the line L equals to 0. First year we have learned the perpendicular distance from Px1 y1 to the line Ax plus By plus C equals to 0 is modulus of Ax1. So 1 by 2 minus y is minus 3 by 2, minus of minus plus 3 by 2 minus 3 by square root of 1 square plus 1 square. So that is equals to 1 plus 3 is 4 minus 2 3s are 6 by 2 root 2. So this is modulus. So 4 minus 6 is 2. 2 by 2 gets cancelled. So 1 by root 2. Now, so 2 into what is r square? R is equals to root 98 by 4. R square is 98 by 4 minus what is d? D is equals to 1 by root 2. What is d square? 1 by root 2 whole square, which is 2. That is equals to 2. LCM 4 2 is 4. This is 98 minus. So 4 by 2 is 2. 2 into 1 2. That is equals to 2 root of 98 minus 2 is 96 by 4. So 4 2's, 4 1's are 4. 4 4's are 16. So 2 root 24. 2 into 4 6 are 24. So 2 into root 4 is 2. 2 into 2 4. So 4 root 6. Third question. Find the length of the chord formed by circle given x square plus y square is equals to a square and the line x cos alpha plus y sine alpha is equals to p. So this is the circle given, which is s equals to 0, and this is the line. What is this line? X cos alpha plus y sin alpha equals to p. So this length of the chord I want. So what is the length of the chord? 2 root of r square minus d square. So r is the radius of this circle and d is the perpendicular distance from the center of this circle. What is the center of this circle? X square plus y square equals to a square is the standard equation of the circle whose center is at the origin, and d is the perpendicular distance from the center of the circle to this line. So this is d. I'll write everything. So circle, for this circle center is 0 0, and what is the radius of this? R is equals to a, and what is d? Perpendicular distance from the center C 0 0 origin to the line. What is the line? X cos alpha plus y sin alpha minus p equals to 0. So what is the perpendicular distance from the center to the line x plus by plus c equals to 0? Modulus of c by square root of a square plus b square. C is the constant here, minus p by square root of square of the quotient of x, cos alpha whole square, cos square alpha plus square of the quotient of y, sin alpha whole square. So sin square alpha, that is equals to modulus. So modulus of minus p is p by cos square alpha plus sin square alpha is 1. So root 1 is 1. So p by 1 is p. Therefore, the length of the chord intercepted by the circle S is equals to 0 is 2 root of r square minus d square. So 2 root of r square is a square minus d square is p square. The next question 4. Find the equation of the circle with center 2 comma 3. So center of the circle is 2 comma 3. And touching the line, this circle touches the line. What is this line? 3x minus 4y plus 1 equals to 0. This is this line. So we need to find out the equation of the circle. Okay. So see here, what is the minimum requirements to find out the equation of the circle? Center C h comma k and the radius r. So here center C h comma k is there and radius is this. The radius is the perpendicular distance from the center of the circle to the line. So this gives us the radius of the circle. So r is equals to perpendicular distance from the center C 2 comma 3 to the line 3x minus 4y plus 1 equals to 0 is, that is ax plus by plus c equals to 0, x1 y1. So ax1, the length of the perpendicular or perpendicular distance from the from P x1 y1 to the line ax plus by plus c equals to 0 is ax1 plus by1 plus c by square root of a square plus b square. So this is 3 into 2, 6 plus minus 4, 3 is 12. C is 1 by square root of a square, square of the quotient of x, 3 square 9 plus minus 4 whole square 16. So 6 plus 1, 7 minus 4 minus 5. The modulus of it is 5 by 9 plus 16 root 25 is 5. So 5 gets cancelled 1. So therefore the equation of the required circle having center C h comma k and radius r E is given by x minus h whole square plus y minus k whole square is equals to r square. That implies x minus h value is, this is h and this is k. X minus 2 whole square plus y minus 3 whole square is equals to radius is 1 square. So implies a minus b whole square a square plus b square 2 square 4 minus 2 2 is a 4x plus y square plus 3 square 9 minus 2 3 is a 6y is equals to 1. Therefore, the equation of the required circle is x square plus y square minus 4x minus 6y 4 plus 9 13. This plus 1, if you transpose this side, minus 1, 13 minus 1 plus 12 is equals to 0. Now, question number 5. Find the equation of the circle with center minus 3 comma minus 4. So, minus 3 comma 4. Touching y-axis. So, already this is a coordinate axis. X-axis, negative x-axis, y-axis and negative y-axis. So, this is the origin. Okay. And this distance clearly gives us, the radius of the circle. So what is this distance? Modulus of minus 3. So the center of the given circle is CH comma K is equals to minus 3 comma 4 and radius is equals to, that is r equals to 3. So therefore equation of the required circle is x minus h whole square plus y minus k whole square is equals to r square, implies x minus of minus plus 3 whole square plus y minus k 4 whole square is equals to r square, 3 square 9. implies x square 3 square 9 plus 2 3 is 6 plus y square plus 4 square 16 minus 2 4s are 8y minus 9 equals to 0. Therefore, the equation of the required circle is x square plus y square plus 6x minus 8y. So, this plus 9 and minus 9 gets cancelled. Plus 16 is equals to 0. Now, let us do the seventh question. Find the equation of the tangents of the circle as x square plus y square minus 10 is equals to 0. At the points whose abscissa are 1. Abscissa means x coordinate is equals to 1. Solution. Let the coordinate of P be x1 comma y1. So this will become, that is, x1 value is 1 comma y1. So implies 1 square plus y1 square minus 10 equals to 0. 1 minus 10 is minus 9, implies y1 square is equals to 9. Therefore, y1 is equals to plus or minus 3. Therefore, the points are x1, y1. x1 value is 1 comma plus 3 and 1 comma minus 3. So, therefore, the equation of the tangent at P 1 comma 3, this is x1 y1 to circle S is equals to 0 is S1 equals to 0. That is x1 plus y1 minus 10 equals to 0. If you substitute, so x into 1, x plus y into 3, 3y minus 10 equals to 0, and the equation of the tangent at P 1 comma minus 3 is x into 1, x plus y into minus 3, minus 3y minus 10 equals to 0. Therefore, the possible tangents are 2. So, one is this and another is this. Therefore, the equations of the required tangents are x plus 3y minus 10 equals to 0 and x minus 3y minus 10 equals to 0. First question from the third Roman. If x square plus y square equals to c square, what is the circle? X square plus y square minus c square equals to 0, and the line L is x by a plus y by b equals to 1. So, L is bx plus ay is equals to ab, or minus ab equals to 0. Intersects a and b, then find ab. So, let this be the circle. Let this be the circle, and this is the line. Intersects means this line cuts this circle at 2 points, A and B. So find AB. He is asking us to find out the chord length AB. So which is 2 root of R square minus D square. Okay. So if this is the circle, what is the center of this? 0, comma 0. Because this is the standard equation of the circle whose center is at the origin. And what is radius? Radius is equals to C, because x square plus y square equals to r square equals to c square, r equals to C. And what is D? Perpendicular distance. What is D? D is the perpendicular distance from the center of the circle 0, 0 to the line L equals to 0. This is S equals to 0. So perpendicular distance from the center is 0, 0 to the line Bx plus Ay minus AB equals to 0. So that is B into 0 plus A into 0 minus AB by square root of the quotient of x b square plus square of the quotient of y a square. So this is equals to modulus of minus AB is AB by square root of a square plus b square. So intersects at A and B, then find AB. So AB is equals to 2 root of r square minus d square. So 2 root of r square is c square minus d square is ab whole square, this whole square. So a square b square by square root gets cancelled, a square plus b square. Further, hence deduce the condition that the line touches the circle. He is asking that this line cuts the circle at A and B. So he further asks, hence deduce the condition that the line touches the circle. So if this chord touches the circle, it will be like this. So this line here it cuts. So he is asking us to deduce the condition that this line touches this circle. So therefore this line L is this now, and this is S equals to 0. So for this chord to be the tangent, the length of the chord must be 0, because this is some length we have. But if this chord is a tangent, then this chord touches this circle, then this length will be reduced to 0, because here we have some length, here some length. Here if we reduce some here, the length will be 0. So if it is a tangent, the length is 0. So that means 2 root of c square minus a square b square by a square plus b square is equals to 0. So squaring on both sides. So this 2, if you transpose this side, 0 by 2, 0. So square root of c square by c square a square b square by a square plus b square equals to 0. So squaring on both sides, we will be getting this. Okay. And if you take this to the RHS, a square b square by a square plus b. That implies if you revert this, so 1 by c square is equals to a square b plus b square by a square b square. This is equals to 1 by c square equals to a plus b by c, a by c plus b by c, a square by a square b square plus b square by a square b square. So b square gets cancelled, a square gets cancelled. Therefore, the required condition is 1 by c square equals to 1 by a square plus 1 by b square. This is the condition that the chord becomes the tangent. The second question, the line y is equals to mx plus c and the circle. So, the line L, y is equals to mx plus c. If you write this in an order, L is mx minus y plus c equals to 0. And the circle S, x square plus y square equals to r square. For this circle, center C is equals to 0, 0 and the radius is equals to a. So, the line, this is the line, this line S is equals to 0 is the circle, this is L equals to 0. This line intersects this circle at A and B. So, given that AB is equals to 2 lambda is given, then show that C square is equals to something is given that we need to show. So, the length of the chord AB is equals to 2 root of r square minus d square. So, radius is equals to a, and what is distance? Perpendicular distance from the center of the circle. What is the center of this circle? Since this is the standard equation of the circle, its center is 0, 0. So, that means m into 0 minus 0 c by square root of m square plus 1. So, that means 2 root of r square is a square minus d square is c square by m square plus 1. But given the length of the chord AB is equals to 2 lambda. So 2 gets cancelled on both the sides. Squaring on both sides. Then lambda square is equals to a square minus c square by m square plus 1. So that means if we take LCM, which is m square plus 1, a square into m square plus 1 minus c square is equals to lambda square. So, if you cross multiply, lambda square into m square plus 1 is equals to a square into m square plus 1 minus c square. So, therefore, if you take this minus c square onto this side, c square is equals to a square into m square plus 1 minus lambda square into m square plus 1. If I take m square plus 1 as a common factor, implies c square is equals to, take m square plus 1 as a common factor, then we will be getting a square minus lambda square, which is what we need to prove. Find the equation of the tangent and normal at 3, 2 to the circle x square plus y square minus x minus 3y minus 4 equals to 0. That means this is the circle and this is the center of the circle and this is my tangent. So this 3 comma 2 is this point of contact P 3 comma 2. So we need to find out the equation of the tangent to the circle at P x1 y1. So and this is the normal. So solution, this is x1 y1. Solution, the equation of a tangent at P x1 y1 to the circle S is equals to 0 is S1 equals to 0. That implies xx1 plus yy1 minus quotient of x, 1 half of that, x plus x1 minus, sign is same, sign is not going to be changed. In center it will be changed. So quotient of y3, half of that, 3 by 2 into y plus y1 minus 4 equals to 0. So that implies x into 3, x1 is 3. So 3x plus y into 2, 2y minus half into x plus x1, x plus 3 minus 3 by 2 into y plus 2 minus 4 equals to 0. So here the LCM is 2. So 2 3s are 6x, 2 2s are 4y minus of x minus 3 minus 3y. So 3 2s are minus 6, 2 4s are 8 equals to 0. So here 6x minus x is 5x, 4y minus 3y is y, minus 6 minus 8 minus 3, minus 9 minus 8, minus 17 equals to 0 is the equation of the required, is the equation of the required tangent. And the equation of the normal is, equation of the normal is, we can find out the equation of the normal in two forms. What is that? So this is 5x plus y minus 17 equals to 0. So this is the tangent, this is the normal. So the perpendicular of ax plus by plus c equals to 0 is bx minus ay plus k equals to 0. That means the quotients are interchanged. So quotient of x of 5 will connected to y and y quotient 1 is connected to x and in between plus is there minus. So that means x minus y 5y plus k equals to 0. First year we have done this in the straight lines. So since this normal is passing through 3 comma 2, substituting 3 comma 2, we get x. So 3 minus 5 into 2, 10 plus k equals to 0. So therefore k value is 3 minus 10 minus 7, if you go to that side, plus 7. So x minus 5y plus 7 equals to 0 is the equation of the required normal. The equation of the normal can be done in another way as well. What is the equation of the normal? Equation of the normal at P x1 y1 to the circle s equals to 0 is x minus x1 into y1 plus f minus y minus y1 into x1 plus g is equals to 0. Here x1 y1 value is 3 comma 2 and gf values. So 2gx x square plus y square plus 2gx plus 2fy plus c equals to 0. So 2g is equals to minus half. 2g is equals to minus 1. G is equals to minus half. And 2f is equals to minus 3. F equals to minus 3 by 2. Now, x minus x1 3 into y1 plus f. y1 value is 2, f value is minus 3 by 2 minus y minus y1 2 into x1 plus g 3 plus minus 1 by 2 equals to 0. So 2 2s are 4 minus 3 1 by 2. So x minus 3 by 2. 2 3s are 6 minus 1 5 by 2. So minus of y minus 3 y minus 2. 2 3s are 6 minus 1 5 by 2 into 5 by 2 equals to 0. So take 2 as an LCM, then x minus 3 minus 5y minus into minus plus 5 2s are 10 is equals to by 2 LCM is equals to 0. So therefore x minus 5y minus 3 plus 10 is minus 7 equals to 0. Plus 7 equals to 0 is the equation of the required normal. This you may compare with the previous method. So you can check both the equations are the same.